Now other versions of the fifth postulate are: if the sum of the interior angles on the same side of the transversal, on the same side of the falling line here, and this PQ is we call it as a falling line, but actually it is called as a transversal. So therefore the sum of the interior angles on the same side of the falling line is exactly 180 degrees, then no intersection of lines will take place. That means the lines are parallel. So very important postulate. Now we have another version, that is Playfair's axiom. Playfair's axiom. For every line L, and for every point P not lying on L, see, we have a line L here, there is a point P here which is not lying on L, there exists a unique line M passing through P and parallel to L. A very important postulate. So if you have a line L there is and a point P outside L, then there is a line M which passes through P and parallel to L. So please remember this. This is a very important postulate again. For every line L and for every point P not lying on L, there exists a unique line. There can be only one line possible, which is the line M here, passing through P and parallel to L. There cannot be another line which is passing through a particular point and is parallel to L. Remember that. Okay. Now two distinct lines intersecting or perpendicular cannot be parallel to the same line or perpendicular to the same line. This is a very important postulate again. Let me again read it for you. Two distinct lines intersecting or perpendicular cannot be parallel to the same line or perpendicular to the same line. A very, very important postulate again. So let us proceed further. Now, having understood the contribution of Euclid in terms of axioms, postulates, definitions and all, let us see what are the demerits of his development in geometry. Euclid geometry is based on many assumptions and undefined abstract words. Please understand this. Euclid's geometry is based on many assumptions, too many assumptions, and undefined abstract words. Euclid's propositions are true for plane figures and is not true for curved surfaces. Geometry is on the edifice of axioms, and postulates used as tools to prove geometrical statements. Geometry as such has an unproved edifice. A very, very big statement. So these are the very important demerits of Euclid's contribution to geometry. Now coming to a statement. Now what is a statement? A statement is a meaningful sentence. Please understand this very carefully. A statement is a meaningful sentence which is either true or false. It can be true or false, but it cannot be both. Please understand. A statement in mathematics cannot be ambiguous. Sun orbits the earth. It is 100% a false statement. All humans are mortal. Please understand, that is 100% true statement. Vehicles have four wheels. It is not a clear statement. It is ambiguous statement. Therefore, a statement, you should understand, is meaningful and it is either true or false and not both. Remember that. Now coming to the next important point, that is counter statement. Very important again. A statement which disproves or counters a statement is called counter statement. One counter statement or one counter example is enough to disprove any mathematical statement or axiom or postulate or a law. Therefore, we call it as a counter statement. One counter statement, that means a statement which counters another statement, is very much is enough for us to disprove any axiom or postulate or a law or a mathematical statement. Remember that. Now axioms. Now as I have told you, we will be discussing about the axioms in details here. Statements assumed to be true. Axioms are statements assumed to be true without proof proof and what we call discussion. Geometry is definitely built on axioms. Lesser axioms accepted would provide a good base for the development of geometry. Axioms must be consistent. Please remember that. Now what is the meaning of that? Axioms are inconsistent if one axiom proves that another axiom is not true. That means if one axiom proves that another axiom is not true, that means the axiom is not consistent, it is inconsistent. Axiom should not contradict. So axiom should not contradict. Remember that. Now deductive reasoning, a method used to prove a statement, is true by applying known statements, axioms, postulates, is called deductive reasoning. So deductive reasoning means a method used to prove a statement is true. So to prove a statement is true, we can use the known statements, the known axioms, the known postulates, and deduce that the statement is a correct statement or a true statement. Now what is a conjecture? A conjecture is a statement which is taken as true and its truth is not proved. Very interesting here. A conjecture is a statement which is taken as true and its truth is not proved. A conjecture therefore may be true or false. That means a conjecture may be true or false. If a conjecture is proved to be true, then it becomes a theorem. So first we have a conjecture, then if we prove it is true, then the conjecture becomes a theorem. Now let us understand what is a theorem. A mathematical statement whose truth is established logically using known axioms, postulates, and then we say that the theorem is proved, and therefore that means the conjecture is proved or the statement is proved, then that is called as a theorem. So therefore a mathematical statement becomes a theorem if it is proved logically. Remember that a conjecture which is logically proved to be true is a theorem, otherwise no. Verification. A method of establishing the truth of a statement. Taking a few examples is called verification. Verification is not confirmed for all possible cases. Now that is what is verification, a very simple explanation. Now coming to the proof. Establishing the truth of a statement logically using the known axioms, postulates, proved statements, giving proper reasons is called as proof. One counter example is enough to prove any statement to be false. So therefore whenever a theorem has to be proved, that means we have to establish the truth of that statement which is given as a theorem logically using known axioms, postulates, and proved statements, giving proper reasoning in order to prove that statement. Now theorem parts. Now once we know there is a theorem, and a theorem has definitely two parts. The first part is the hypothesis and the second part is the conclusion. Now in proving a theorem, please understand this here, there are two parts here. So to prove a theorem, constructions can be done, known axiom postulates can be used, proved statements can be used. Please understand this. Known properties can be used, known laws can be applied, hypothesis can be used. All the statements are written giving reasons. Logically, step by step, the theorem is concluded with proof. So that is what is the procedure of proving a theorem. Now steps of proving a theorem are: a proof begins with strong intuition, knowledge of basics to draw logical conclusion, various different possibilities to arrive to conclusion, find the best suitable logical conclusion as proof to the theorem. So therefore these are the various steps in proving a theorem, and this we will understand with many examples, because we will be learning about theorems in different chapters of geometry. There you will understand exactly how a theorem is proved with these logical steps. So learn these basics of geometry, contribution of Euclid, and the various definitions, various statements, what is a theorem, what is conjecture, etc. And please note down in a book for your future reference. Thank you.